Now, one thing to be mindful of is that Newton's method doesn't always work. It's something we can use to try to improve our guesses, but there will be times when, for whatever reason, we don't get the answer that we're looking for. So here's a different cubic, and I've gone ahead and graphed this in Desmos, and its root is going to be somewhere here close to -2. One of the problems I could have is if I make a bad guess. So I have set this up where I can make a guess, and I've chosen x equals 1. Well, where's my tangent line for x equals 1? There it is. Again, it's a horizontal tangent line. So when I go to iterate, I can't. What's my next guess? It would be 1 minus, well, the original function evaluated at 1, sure, divided by the derivative of this function. What is the derivative of this function? F prime of x is 3x squared minus 3. That's going to be 0 when x equals 1. So my iteration just stops dead in its tracks. So one thing I could try is, okay, that was kind of a silly guess anyway. I know that my root is supposed to be close to -2. Let's try a equals -2. Now, I've got a whole bunch of stuff showing in this graph all at once. So let's take a look at it. In blue here is the tangent line. Let me zoom in a little bit. Here is my original guess, x equals a. And yeah, I got a lot closer to that root that I wanted. So just like on the slides, I'm going to draw in a vertical line at my next guess, which is right here in, well, Desmos wants that to be purple. It's a little bit easier to see if I get rid of those grid lines. So then here is my next guess. X equals -2.444. All right. So I'm going to say my next guess is -2.444. Ooh, all right. That's a lot closer now. So my second guess is -2.444. And I have to zoom in really close in order to see the differences between these things. So here's where my tangent line crosses the x-axis at my next guess, my third guess, -2.3591. And again, that's not exactly equal to this root, but I'm getting closer every single time. 3591. So here is my guess after that. In blue is my tangent line, and that actually covers up the function pretty well. So again, after just 2 or 3 iterations, I am so close to the actual root here that Desmos cannot tell the difference between these two numbers, at least not until I zoom in significantly more. So again, here's the actual root right here at -2.3553, and my guess was -2.3591. I was close, within just a couple 1/100ths of the actual value. And if I zoom all the way back out again, from here, I can't even tell the difference between those numbers. Now, this process, I can sometimes have a poor choice of my first guess. There's going to be some functions where this doesn't work at all. So let's change it up. I will disable these graphs for right now. Let's look at the function x to the power 1/3. This is kind of a boring function to find root of. I already know 0 to the power 1/3 is 0. But let's see how well Newton's method does. Sort of a check to make sure this is still making sense. Now, I'm going to make a guess. The nature of guesses is that it's not going to be exactly the right number, right? If I just put in a equals 0, my next iteration, well, this slope is vertical, it's undefined. My tangent line here is completely, it has an undefined slope. So I would need to make a guess. Let's say a equals 1/2, like so. Show me that coordinate. There it is. Show me that tangent line. There's a tangent line. And, oh, is it me or did that tangent line get farther away from the root? There's x equals a. There's x equals the next guess. Yeah, my tangent line got farther away. What value of x is that? X equals -1. Okay, well, we'll try to make the guess better. We'll put in a equals -1 and, okay, show me the point. Okay, there's my guess. Show me the tangent line. I got farther away again. What's my next guess? My next guess is going to be all the way out here at x equals, excuse me, all the way out here at x equals 2. There it is. Okay, well, x equals 2. Here's the point on the graph. Here's the tangent line. And where's my next guess? It's over there at x equals -4. Okay, let's try x equals -4. My guesses are getting worse every single time. Where's the point? There it is. Where's the tangent line? There it is. What's my next guess? X equals 8. These guesses are getting worse. I was promised guesses that would get better. What's the deal? Let's take a very, very close look at this formula to understand when Newton's method can just not work. So my next guess says, take my old guess, subtract off the value of the function, that guess, divide it by the derivative of the function. Well, what's special about this function right here that didn't happen before? As I go out farther, the derivative of this function goes to 0, right? This function is x to the power 1/3. So its derivative, f prime of x, that's going to be 1/3 x to the power -2/3. Or I could also write this as 1 divided by 3x raised to the power 2/3. So this derivative is actually flattening out, right? As my x grows larger, the cube root of x squared can get as large as I want, but this derivative is going to 0. And that's a problem for this formula. So if this derivative is 0, the iteration is just undefined. I can't divide by 0. But if the derivative is close to 0, then what my correction factor here is actually too big. I'm dividing by a number that's very small. And what does that do? That throws me off to some other part of the function where the derivative is even smaller. And that means that my iteration is wrong by even more. So the thing to watch out here is that Newton's method can fail, and it will fail, if f prime of x is too close to 0. So we saw that in my first example here, where I just picked a bad value of x. And I got, well, on my first iteration, the derivative was just equal to 0, and I had to stop. I can't divide by 0. But on functions like this, my x to the power 1/3 here, when the derivative of my function is too small, then this subtraction here, the thing I am subtracting off, f of x divided by f prime of x, that's going to be too big. And instead of making my guess better, it's making my guess worse at every single step I repeat. So I drew in some guess. I followed my tangent line. I found where that crossed the x-axis, and that gave me another guess. And I drew in another tangent line, and I did the same thing. Every single time, I'm going farther out on the function. The derivative is getting smaller every single time. And then that makes my estimates worse and worse and worse. So again, Newton's method works as long as my derivatives are not getting close to 0, but it absolutely can break and fail to converge if my derivatives are getting closer to 0 instead.